All right, one more problem, problem 49. This time I'm going to give you a head start. I'll probably give you, looks like about a 5-minute head start. Please get started on this problem. Problem 49, chapter 32. We're trying to find impulse. Miller, what's the symbol for impulse? Or? I or J. This is a great problem because it's asking for impulse. But I don't know how to find impulse. Thoughts? Change in momentum. Impulse is just equal to change momentum. So what you're trying to find here is the change in momentum. Mass times velocity final minus mass times velocity initial. What is the velocity initial? 0. Class, is there friction? No. Is there a force applied? No. Therefore, conservation of mechanical energy. Can you use uniformly accelerated motion? No. Because as they get closer, the force of gravity is going to change, therefore the acceleration is going to change. Therefore, we need mechanical energy initial equals mechanical energy final. This is our initial position. This is what it looks like. This is our final position. As they collide, we have R and R. Mechanical energy initial equals mechanical energy final. What sort of energy, Emily, do the two spheres start with?
Gravitational potential.
Gravitational potential energy. So PEG sub I. The velocity initial is equal to 0, and there's no spring. What sort of energy do the two objects end with? Gary.
Kinetic.
Kinetic energy.
And gravitation.
And gravitational potential energy. Okay. From left to right, Vlad, what's the equation for the gravitational potential energy initial of the system?
Negative G M1 M2 hold it the same as, which is 2M over big R.
Well, I'm just going to write the equation out first, then we'll substitute stuff in. I agree with all that, but bless you. So on the right-hand side, kinetic energy final. Potterella.
For kinetic energy final, is that 1/2, just one of the M's. They're the same, right?
Both of them have the mass,
Yeah,
yes.
so you can
Yep.
just add. And then velocity final is what we're trying to find, the squared.
Keep going on the right-hand side here.
Just minus G M1 times M2 over 2 little r.
I'm just going to put R final for now, but yes, we'll definitely put that in there. What's missing? John?
Isn't there another kinetic energy for the other?
I'll put kinetic energy total final because both objects are moving, therefore both objects have kinetic energy final. Substituting in our letters here, we have big G M over big R is equal to 1/2 times the mass times velocity final, bless you, squared, minus big G, mass, they're both the same. As was pointed out here, 2 times little r is the R final, plus 1/2 mass times velocity final squared. Everybody brought a single mass to the party. V final squared over 2 big G M over 2R plus V final squared over 2. So this is equal to V final squared minus big G M over 2R. Therefore, velocity final equals big G M over 2R minus big G M over R, the square root of, or I suppose big G times M times the square root of 1 over 2R minus 1 over big R. Our goal here was to figure out the change in momentum or the impulse, which we figured out was equal to mass times velocity final. So this is equal to, okay, so I missed the square root there. The square root goes with the whole thing. Like so. So we have mass times the square root of big G m times 1 over 2r minus 1 over big R. In order to get that mass underneath there, we have to square it. So we get big G mass cubed 1 over 2r minus 1 over big R, the square root of. That's part A. Part B is to figure out what would the impulse be, or the change in momentum be, if on one of them during an elastic collision. If it is an elastic collision, what do we know about when two identical objects run into one another? What do we know about the velocities? Sierra. Their kinetic energy is conserved. I agree with that, but I'm looking for a little bit more. I agree with that. What do we know if the two objects are identical and we have an elastic collision?
Momentum is conserved.
True, I agree. Momentum is conserved and kinetic energy is conserved. How does the final velocity compare to the initial velocity if it's an elastic collision with two identical objects? Ponderella.
They're like opposite though.
It's going to be the same or in the opposite directions. They have the same magnitude with the opposite direction. So notice that the velocity final would just be negative with the same magnitude. Ladies and gentlemen, we'll have a beautiful day. Thank you much.